So we're going to spend one more day reviewing how to simplify radicals, because tomorrow we're going to add, subtract, and multiply radicals, which is hard to do if you have no idea how to simplify.
Actually, this is already going.
Now, we want to take what's inside the radical, the radicand, and break it down into its prime multiples. So if I look at my first prime number 2, does 2 go into 24?
Yes, 12 times.
12 times. Does 2 go into 12?
Yes, 6 times.
6 times. Does 2 go into 6?
3 times.
3 times, and 3 is prime. So 24 is 2 times 2 times 2 times 3. Now my index, or my root, what number is here?
It's going to be
This is assumed to be a what root?
2.
2, square root. This tells me how many sets I'm looking for. So I'm looking for a set of 2.
So 2 and 2.
Which I have one set here, and is there another?
No.
No. So we'll stop there. Now, what I didn't circle, what I didn't find sets of, 2 and 3 stays inside. 2 times 3 is 6. And what I did circle comes outside. Now note, I did multiply 2 times 3, and I got 6. Here you're not going to multiply 2 times 2 and put 4. You're going to put the set you found, which was 2. Now technically you are multiplying it, because what's 2 times 2?
4.
Inside of here is the square root of 4. And what's the square root of 4? 2. So make sure you don't get confused between what you multiply, what that stays in, and what comes out and you don't multiply. So square root of 24 simplifies to 2 times the square root of 6. What's that? Oh, and then you can use the calculator, yes, to check your answer. Make sure you get the same decimal between these two. As we look at fractions, variables, they work about the same way.
It goes so simple.
So let's have you help me work this through. I'm looking for the fourth root of numbers. So again, let's do our prime multiples. Does 2 go into 405?
Yes.
How many times? No, it doesn't. Okay, let's try 3. Does 3 go into 405?
Yes.
How many times?
135.
135. Does 3 go into 135?
Yes.
How many times does 3 go into 135?
45 times.
45, thank you. Does 3 go into 45?
Yes.
How many times?
15 times.
Okay. And does 3 go into 15?
Yes, 5 times.
And 5 is prime. Thanks. So 405 is 3 times 3 times 3 times 3 times 5.
Oh, 4 pairs. Sets of 4.
Oh, we're not there yet. X cubed has how many x's?
3.
3. And then I have 2 y's.
Sure.
Now I'm talking about a fourth root, so I'm looking for how many sets?
4.
I'm looking for sets of 4. Where do you see sets of 4?
3.
All these 3's, and
And then that's it.
that's it. Okay. That's all my sets of 4. So what stays inside?
5.
5
X to the y squared. Y squared.
x to the cube
And then y squared.
and y squared. Now what goes outside?
3.
Just a 3, right?
Yes, sir.
And we're talking about the fourth root. So the fourth root of 405 x cubed y squared simplifies to 3 times the fourth root of 5 x cubed y squared. Like so.
Let me check our answer.
Yeah, you can check your answer. It won't work too well with the variables, so you just have to check with the numbers. Now we are going to get a little bit more complicated today than you will see on the test, but it just helps with your practice. So let's simplify 175 m squared in 9p. Let's break down 175. Does 2 go into 175?
No.
Does 3 go into 175?
No.
Does 5 go into 175?
Yes.
How many times does 5 go into 175? How many?
35.
35. Does 5 go into 35?
Yes.
How many times?
7.
And 7 is prime. So 5 times 5 times 7 is 175. I have 2 m's, 9 n's, and 1 p. There you go. Now I'm circling sets of what?
2.
2, right? Let's assume this is square root. So I have a set here. Where else? M.
And 4 sets of
And then 1, 2, 3, 4 sets of n. Very good. So let's see what stays inside. What did I not circle? 7 in P. So 7 in and a P. And what goes out? 5
M
M.
squared.
Squared.
M comes in.
So 5.
5M.
5M. Just one M, right? I only circled the one.
And then, N to the 4.
Very good. Into the, how many did you circle? 1, 2, 3, 4.
Okay, that's fine.
So there we go. We're simplified.
That's so easy. So confused.
Good. I hope so, because it'll make tomorrow easier.
Yeah.
Now.
Never mind. I spoke too soon.
Now, what did I say about numbers on the outside of a radical?
You put them inside.
No. No.
I don't know.
We save it for later.
Oh yeah, fair play.
So let me take this and move it over here, because I just want to focus on, right now, simplifying the radical. So this is going to be long. 384. 2 goes into 384 how many times?
192 times.
192. 2 goes into 192?
96 times.
96? Okay, thank you. 2 goes into 96?
48 times.
48. 2 goes into
24
48.
times.
What?
24 times.
24.
12 times.
2 goes into 24.
12 times.
12 times. I might be losing track here. 2 goes into 12. 6 times 2 times 3. Can somebody make sure we got everything? 2
Yes,
times
you
2
got
times.
it.
Does this all equal
Yes.
384?
Yes.
Okay.
Good.
Now I'm going to leave x to the 20 as x to the 20 for now, because I don't want to write 20 x's. But there is a shortcut. We'll see. I have a y and then 9 z's.
Shut your mouth.
All right.
Now we compare the two.
So what are we circling? Sets of
Two.
2's. So I have what?
10 sets of X. 2.
1, 2,
3.
3. I have nothing else with the numbers. No sets of y's. How many z's?
1 0.
4. And then
10 sets of X.
10 sets of x, right? Because 20 divided by 2 is
10.
10. Okay.
So that will equal 6x 10 x.
So let's see.
What?
6. What stays inside?
X 10.
No, not x10, because that's what comes out.
Oh yeah, yeah.
Because I'm circling 10 pairs, right?
Y.
Y and a z.
Yes, sir.
Now on the outside, what's 2 times 2 times 2?
4. 16.
8.
Nine.
Wait. Wait. 2 times.
2 times 2 is 4. Times 2 is 8. How many x's came out?
10.
10. And how many z's came out?
4.
4, right?
You're an idiot.
Now remember this that we took out, we set it aside.
Now we combine like terms.
Now let's bring it down here and multiply.
Multiply?
Yes, we're multiplying because that's what's going on right here, right? Multiplying. So now I need to multiply this outside to what came out together.
40.
So 8 times 5 is 40.
X.
X what?
11 to the power of 11.
So there's 1 plus 10 is 11. How many y's?
Y cubed.
Y cubed.
And then Z 8.
Very good. 4 plus 4 gives me z8. And that's all times the square root of 6y z.
Yes.
Finally, we're there.
Angel, do you understand?
We're
That's
done.
so, that's so easy.
What?
That's so easy.